So I'll share my screen. Let's start another 4 minutes as soon as everyone joins.
बाहर जाना है।
हाँ बाहर जाना है।
रिटर्न वाला स्टैम्प मेरे नंबर देना। हाँ रिटर्न वाला स्टैम्प दिए।
मोबाइल नंबर बोलिए। मोबाइल नंबर 94821 94821 0 5608 पोर्टर है भैया 08 है पोर्टर है। गाड़ी नंबर K05 AJ 5325 भैया
नंबर দিয়ে ছেড়ে দাও। ও নাম্বার দিয়ে দিয়েছে এখানে।
নাম্বার কোথায় দিলাম? নাম্বার তো তোমাদের 400 3 হয়েছিল না 81 না মতো 4 হলো। तो पहला बार लेके जा रहा हूँ इसलिए मालूम नहीं है।
মোবাইল নাম্বার নিয়ে নিয়েছো? মোবাইল নাম্বার গাড়ি নাম্বার নিয়ে নিয়েছো?
होते भैया
हो गया।
ड्रॉप किया वो लेके ले गया वो ये तो पहला बार।
ओके
Hope my screen is visible to all. Can someone please confirm on the mic?
Yes.
All right. So we are primarily looking onto a platform called afso.org. Now, AFSO is nothing but American Association of Variable Star Observers. So this platform is where various observers from around the world have put in their observations, and it's a non-profit scientific organization, and it goes back in time since 1911 on a manual note, and the database was collected since then, and it is now available to all via the internet. And it'll have some coordinates, collects, and analysis of some observations of variable stars that some professionals, professional astronomers, and even some citizen scientists who have worked on some citizen science projects have also uploaded. So I myself have uploaded a few observations onto this website as well. So all of these observations collectively will be available to around the world. Later, when they do observations, when they do analysis or studies further on certain stars or certain celestial bodies that you have made prior observations on. Now, let's see what AVSO does. So AVSO will basically collect variable star observations, and that'll be doing from amateurs, professionals worldwide, and it'll be having some optical, infrared, some spectroscopy, photometry, CCD, DSLR, as well as some visual, naked eye visual observations and estimates. So it maintains an international database, and this is because it's one of the largest and longest running variable star database that we have currently in the world. It has over 100 million observations on the database in itself. Now, it provides us various tools and softwares, like as you can see here, VStar. Now, VStar is a light curve analysis tool, and VSX, or Variable Star Index, is a database of some variable star classifications. Yeah, some variable star classifications, and we have light curve generator that will give you some real-time light curves plotted. APAS, or APASS, is All Sky Photometric Survey. So that will give you some photometric survey from the celestial bodies of different skies at different time. Like, for example, right now in India, we have the winter sky. So if you want some photometric survey from the summer sky, or from another part of the world, or from another coordinate of the world, you will be able to still observe that, or achieve those data from this database based on lifetime coordinates entry. Now we have something called SHET. SHET, or CHET, is a charting tool for observations. So not only does it give you some observations, but also gives you some sort of chart that compiles all of your observations. Now, it widely supports a lot of researches like supernova progenitor studies, exoplanet transit timings, then some CFeed work. That is when you have to compile the studies and give you some what do you say, an accumulated, a compiled version of your studies, and it give you some cataclysmic variables and some dwarf Norway reports, and some AGN variability. Hope you can relate to that term here. Active galactic nuclei variability as well. Then it'll give you some follow-up work on some existing satellite images as well. Now, the main reason why AFSO is such an important place is that it sort of democratizes astrophysics. Like, anyone with a small telescope or even a DSLR cam can contribute to some real scientific data that is used in reviewed research. Now, all you have to do is maybe click a few pictures, and it'll give you what you observe and how to analyze your observation. Now, let's say again, if you're unable to click pictures, you have other softwares like I was talking about the other day, like LCO portals or exospice.com, wherein they all give you some images that they have observed and recorded on your behalf upon your request. So basically, by just remotely sitting at a place or sitting where you are right now, you will be able to collect images, live telescopic images, and you can analyze it by yourself without having any prior observational setup. So that is what tools like AVSO helps you with. Now, AVSO has various different features which you will be looking onto and exploring on your own. But primarily, I will be discussing here about the variable star plotter and photometric table. So I'll give you a little idea about the variable star plotter. Basically the light curve plot, actually, more than variable star plotter. So the light curve plot is another feature that you can come across on AVSO, wherein you will be discovering things about some plots wherein you can give me a moment. I think this should give you a clarity. Yeah. So this is the major idea of a variable star plotter, or rather a light curve generator. So it'll give you light curve generation. Now, this is a light curve that is not generated according to scale. I just generated quickly for the session. Now this can be now these points will be more scattered. Like, if you remember, I had discussed in a previous session, I had shown you some light curve generators for a data that was calibrated and uncalibrated. So according to that, you will have y-axis and x-axis, wherein y-axis will be about magnitude, and your magnitude based on, if you have a lower number, it'll be a brighter star, and if you have a higher number of magnitude, it'll be a less brighter star. And your x-axis will give you the Julian days, that is the calendar days that we have. And the colored points will have some individual observations, and the symbols like VB, RICCV, all those are various filters that you use. Like, for example, visual filter, basic filter, infrared filter. So all the RGB filters plus a few other biased filters. Like if you remember some reduction frames I've discussed before about. So those will be also there, and these reduction filters will also be contributing to some optional fitted curves, that is your smoothing or some Fourier curves. All these will be mathematically analyzed as well. So even MATLAB is being utilized here. So you can look at the time between repeating peaks or dips, if you have a scattered image. Now that is easy to generate. I'll show you on the platform shortly. And so in this way, you will be able to calculate the period of the event that is taking place, from 1 through 100 days, or any sort of eclipsing binary, or any deep repeating dips can give you data on eclipses and some, what do you say, various other phenomena that take place. So you will also be able to understand about the amplitude of variation, that is like the difference between the maximum and minimum magnitude. Uh, for example, when you have a large amplitude between magnitudes, you will have something called a Mira variable. When you have smaller amplitude, it's called the delta skew-tie. So based on Mira variables and delta skew-tie, that is large amplitude and smaller amplitude, you will be able to figure out a lot about the magnitude, as well as the dips and curves that goes into it as well. Now, if you have some flat curves when you observe, that is, some flat curves would tell you that there is a constant star, or it can also mean a noisy data. Now that you will be able to understand only when you reduce your raw images and raw data. So in the reduction, if you lose the flat curve, it will mean that it is a constant star. If you don't lose your, if you don't lose your flat curve, it will be a constant star. And if you lose your flat curve during the reduction, it means it was a noisy data. So that is why your reduced images compared to your raw images is very important. Now, again, your light curve shape will give you a lot of information. Now, that will give you some, what do you say, if it is an asymmetric shape, for example, like there is a sharp rise and some slow falls, etc. That shape is what is called a C feed. All right. And if there is like a steep drop, okay, and some v-shape sharp data, then it is a next eclipsing binary. Then we have some irregular spikes, so that will give you some dwarf nova, cataclysmic variable. So that variable is associated to dwarf novas. So all these will give you various ideas of what kind of plot you're looking at. And even the filter comparison, as you can see on the top, it gives you a lot of filter comparisons, wherein you will be able to compare various filters like basic filter here, visual filter here. So all these filters will be giving you some, how these filters are interconnected, and how the magnitude are changing, or the temperature changes happen, or some sort of hot cool phases are shown, etc. Like for example, if we in this graph, this may not be very clear to you, but when you work on the on the platform by yourself, you will be able to understand that, like for example, in between, if you see that the B, that is a basic filter, increases more than the visual filter, then the star is getting more bluer, right? So if it becomes more bluer, then naturally it is indicating that the star is more hotter. And the other way around, if it is coming from a visual to a basic, then you can see that it's getting more less bluer or kind of tentating towards red. So you can understand that the star is getting colder or losing its heat. So all these can be understood. Also, detecting some outbursts or unusual behaviors can also be understood. Like, for example, nova outburst, or some dwarf nova eruption, some AGN flares, some sort of things like that. You can even compare data from two times, and you can even look at some changes in the data and understand there is some long-term evolution happening as well. So all these are little ideas to give you about the light curve plotting. Let's move into the major agenda of today, that is the variable star plotting. So variable star plotting, I'll be shortly showing you how to obtain a variable star data from your from the APSO website. Meanwhile, if I can give you some idea about it. Now, identifying a variable star on your variable star plotter is fairly simple. It'll have some sort of, what do you say? Um, some what do you say, some mark on it. Either it'll be mentioned as a V, or it'll be mentioned as an empty circle or a crosshair, or some, crosshair is the symbol like the target symbol. So it'll be mentioned as that, or it'll be one circle that does not have magnitude mentioned on it. And even the numbers that you see around these around the stars on a variable star plotter would give you a visual estimation, and it'll give you various idea about the photometry. I think it's more better if I share and discuss with you. So, okay, I will just give you a gist of what all you need to be careful about. Like, for example, you need to identify the variable star first, then you need to identify what the numbers are around it, then what orientation this particular star plotter is giving you to identify the north, east, south, west. And most of the star plotters will have the directions mentioned on it. If not, you will be able to uh, take it through an astronomical orientation, or if you have a telescopic view right in front of you, then you can compare it with your real image as well. And yeah. So again, your field of view is very important. They'll be asking you about what kind of scale or what kind of field of view you would like to use here. And your magnitude sequences will also be taken into consideration, where you need your color index and errors, magnitude, label. All these will be taken into consideration once you get your star plot, and you will be able to identify what values are what. So I will quickly then move to the website so you can see. Okay, I think I already have it open. I'll once again share. Give me a moment, please. Oh, I'm not sharing. Okay. Hope my screen is visible. That is of Edge. A new tab is visible.
Yes, madam.
All right. Okay, so here we'll be typing in www.avzo.com. So you will be getting this particular. Is it changing for you all?
Changing, madam.
Okay. All right. So you will be getting this particular screen where you have various various actions required. Like you can, if you already have your data, you can submit and access the data that you have. Submit as in you're submitting under the European Space Agency, and so that will be the final assessment that will be accessed by around the world. And you have tools and observer resources. You have observing sections. We have education and various course and materials that you can undergo to operate this particular platform as well. So yes, so here we'll be first going through tools and observer resources. And here again, you have light curve generator. That's what I discussed earlier about. So if you go to light curve generator, uh, you can put your like for example, we can put WASP 84b. That's what I had worked on. So you can adjust what however you would require, and yeah, you can try to send. And the more you make your options complicated, the more it'll take time as well. So you can even see the contributors to this plot. There are more contributors, and as well as you can see the chart as well. So apart from this chart, you can enter any star. Excuse me. You can enter any star's name here. If the let's say if the light curve generator on this website has that star already recorded by other people, then you will have the light curve data generated from here. If not, you will have to, like, if not, that's a chance for you to work on that light curve plotting, and you can upload it here by under your name. So that is one area where you can look into. Now today, so there are other options as well. There is variable star index, data analysis, data entry, photometry tool, etc. So all these you can even have videos on this platform which will guide you through how to use each of these. Today we'll be looking into the variable star plotter, because that is very important. When you observe a star, you need to have a comparison star to help you guide to reference the star that you're looking for. Now, for plotting a quick chart, now I am giving SS Cygni here for now. This space is usually empty like this, so you can type the name or the ID of the object that you're looking for. Now I've chosen SS Cygni for now because we have already worked on that particular star, and we must be more um, familiar with the star. Now we look at a chart scale. So I usually give a D, that is 60 arc minimum, based on how zoomed in you want your scale to be. Because 60 arc minimum would give you like an average, like it's somewhere in the middle. So it won't be too zoomed out, it won't be too zoomed in. So if it is too zoomed in, what happens is you won't be able to accurately see what is on the neighborhood of your star. And if it's too zoomed out, you will see a lot of stars overlapping with each other. So giving a C or a D would be the safest choice. So I give a D. And you can always choose a visual chart orientation. Uh, that is where you find your star plot in the most understandable way. If you choose a CCD, reversed is not an option, because reversed comes when you use a telescope, and if you want to reverse your chart so that it'll have a reverse image when it comes onto your telescopic view. Now, is again, you can use a chart orientation if you're using a CCD camera, but for normal chart orientation, I'm choosing a visual here. Now, we will choose a chart. Okay, so since we are first going on to a variable star plotter chart, and then later we'll come back and move to photometry as well. Also, if you go down, you will be able to see how you want your field of view. You can keep it 59, 58, or if you can increase it up to 60. So I'll try with a 30. We'll see how that goes. Uh, so the magnitude limit also you can set your resolution, all based on your, these advanced options are based on what kind of telescope you use, right? So and like what orientation you require is based on what kind of sky you are watching currently. And so all these can be filled up according to your liking, and you can plot a chart, right? So it'll take a few seconds. Okay, I'll just go back and set it back to 60 so you can have a better field of view. Yeah. So this is one field of view you can get. So this is a sample of a variable star plotter. This is of SS Cygni, as you can see. It has given you the maximum magnitude to be 7.7 and minimum magnitude to be 12.4. And so if you look here, you can see a crosshair like marking on the dead center, and that is where your star is. And now one thing that can confuse you is that okay, so out of all these images, my target or my crosshair indication shows somewhere with no star in the middle. Now that is a confusion most of us can have in the beginning, but now the thing with that is, so usually when they give you a crosshair indication, there is actually a star right there in the middle, but that crosshair indication is not transparent. So this white region is actually covering it up. Okay, so that is the indication, but actually there is a star there. So that star, we can one thing we can identify from this situation is that this star, the what do you say, the size of the star is fitting inside this circle, right? Now fitting inside this circle, or if let's say if our target was this circle, and if the cross hair was on this, the middle portion would be white, but you can still see the black region outside. So we can assume that this star is somewhat only this much when we see on the chart. Now that is one easier way for us to understand the various aspects of this of this chart. Now let's go from the beginning of this chart. Like for example, um, okay, we have, yeah, okay, so we see a few other stars and the magnitudes are mentioned here. We have a star somewhere here with a magnitude of 128. We have a star here with a magnitude of 109, here with 134, and this with 98, this with 119, etc. Now, now let's begin to read this map while observing. Sorry, give me a moment. Yeah. So here we have already identified where our SS Cygni is. Our SS Cygni is here. So all your neighboring stars are this. Now, if you're observing uh, through a telescope, the usual method we adopt is we try to plot three prominent stars in the vicinity. Like here, if you quickly look at it, three prominent stars would be, one is 86, one is 98, and one is this, I think that is 96. Now, if you have any confusions regarding what star this is pointing to, then you change the scale of this image or field of view of this image, and then you replot your chart. So if you have at least like 2 to 3 replotting of the chart, then you will be able to compare and understand what is where. Okay. So in this vicinity, I take these three stars and then try to draw an imaginary triangle. Now, on one side of the triangle is this much, is this marking. Now I try to zoom into that and I try to visually plot a space like this. And then if I have some sort of platform or like an Excel or something, wherein I can identify how many, how much of an angle away is this from the imaginary line drawn across, then I will be able to easily plot that on a live view using a telescope. Again, coming back to reading things on this chart, we can see these tiny letters here. This is S, E, N, and W. So naturally, you can understand these are about directions. That is one another way. I mean, one of the most important ways you need to set your stars. Like, for example, when you're observing live through a telescope, you will know which is the north or which is the south, which is the west, which is the east. So it's always important that whatever view you are able to see through the telescope, that obviously you can't change because that is one set view that you are able to see through the telescope. But you can come back to this chart and reset it based on the directions that you require. In the previous page, you could set the directions and you can come. So that will also help you to plot your variable star quicker. Now, yeah. So once you have figured out your directions, you can, yeah. So, like for example, we have an FOV or field of view of 60 in this. That means uh, 6 degrees, the full chart width is 1 degree of the sky. Okay, so if I have 60, then your full chart width is 6 degrees of the sky. Okay, if I'm keeping a 30 of FOV, then my full chart is showing a 3 degree of the sky. So that is how you identify your FOV using your chart as well as what you set. Now, you must have noticed a difference when I kept my FOV as 30, I had a more spatial chart. Like, for example, when I kept it as 30, my chart was not as congested as this. Okay, that
भाजी
was
भाजी
because
দিয়ে
I
এসে
was
আজকে
considering a 3 degree width of the sky when I was looking into the chart. Now, since I've made it more zoomed out by taking 6 degrees of the sky onto my chart, that is when I kept as 60, then that is why I can see a lot many more stars on my chart. Hope that's clear to you. Any doubt up till now?
madam if, can you repeat it little
Yes. What part would you like to repeat?
how you select 3 star mm,
Sorry?
how you choose three star in from graph
Oh, about these three stars?
yes yes madam
Yeah, so I was saying if when you have a telescopic live image in front of you, when you're observing on a telescope, or let's say you've got some telescopic images from any other sources, how do you understand or how would you correlate this chart with what you're watching? So what you do is, first of all, you identify what directions have you kept your telescope, as well as what directions are your chart. Based on that direction, you identify three prominent stars that you can visibly identify on your chart. Now, here, if you see three prominent stars, this is our star location, and your three prominent stars would be 98, 96, and 86. It doesn't have to be the same. Whenever you look at the chart, whatever is feeling prominent to you, closest to your variable star, that's what you choose. So I'm choosing 98, 96, and 86. And I try to draw an imaginary triangle based on this. And I will try to find the scale or the angle from, how much away is this star or the variable star that I'm observing is from the imaginary line that is passing via 98 and 86. Then I'll be able to see, okay, where exactly the star that I'm looking for is and where my neighboring stars are. Hope that's clear.
Clear, madam.
uh, to avoid an infinity mirror don't share your entire screen. Okay. Oh my god. Okay. All right now. Okay. So hope that's clear about the that is just to locate where your star is based on the chart and based on your telescopic view. Okay. Now if you see here, we have discussed about FOV and your magnitude limit. Oh, yeah. So the magnitude limit. Magnitude limit is given as 14.5. Now that is the default that comes. You can manually change it to however you want it to be. Now 14.5 means that the stars fainter than 14.5 magnitude limit will not appear on your chart, which means all the stars that you see on this chart or whatever is visible on this chart is having a limit of at least 14.5 magnitude. Okay, now let's say if you reduce the magnitude limit from 14.5 to 7 or 8, you will have not many more stars visible here because the stars that is having a magnitude of 8, 9, 10, all those will be visible here. So you try to keep a safe, let's say if you already know your variable star is of a magnitude of 80, so you can keep uh, somewhere from 50 or 20, 25, from that range onwards. So you can compare the magnitudes of different stars. So that is again a manual correction that you can make. So the stars drawn bigger and darker are more brighter naturally, and smaller dots will be fainter. Okay. So, if there's one thing that you observe, you might have observed that uh, bigger and blacker circles that you see, like for example, here it is a big circle and black circle, so that is 86 of magnitude. Okay, but you see the small one that is of 114. Now, that might confuse you a little bit because, I mean, the bigger means bigger number and smaller means smaller number. No, the magnitude is always going in the inverse way. Now, more the magnitude, the brightness will be less. Lesser the magnitude, the brightness will be more. So that is one thing we need to keep in mind. So an 86 would be somewhat like very bright, but 114 compared to 86 would be less brighter. That's why it's shown this way. Now, that is one thing you need to keep in mind. Now, okay, again, coming back to these numbers. So we see these 109, 98, 134, 114, etc. Taking 98 for example, 98 is a number allocated, but 98 is not the magnitude. Okay. Now, the magnitude that you think are in the tens of the magnitude, as in when you record it, it's in the tens of a magnitude. So here you can take it as 9.8 magnitude, and here you can take it as 10.9 magnitude. Then here, bigger one, you can take it as 8.6 magnitude. So all these are not, I'm not saying that the magnitudes are changing, but what we have to understand here is the magnitudes will be 109 or 98 or so. But when you record it as 9.8 or 10.9 and 13.4 12.8, etc. Okay, now this is for the ease of your calculation. You're just reducing the scale to 1/10. Okay. Now, this is how you will be recording when you record it in a tabular format, or for any further analysis, you will be recording it in 1/10 of the magnitude. Okay. Now, this is you can these values, you can use them to either do your analysis visually, or any CCD comparison of the brightness of the SS Cygni, etc. Now, for some visual estimation, you will have to compare this SS Cygni's brightness with stars that are brighter and fainter. Or for CCD photometry, you can use a photometric table. Now, let's say we are not going for a photometric table and we are trying to do a visual estimation. Now, for a visual estimation, you can see that, okay, this is our variable star. Now, we know 98 is a bright star and 109 is not as bright as 98. Okay. So the same goes with, let's say, 119 and 128. Now, 128 is a lesser bright star compared to 119. So keep in mind, always bigger the numbers, lesser brightness, smaller the numbers, bigger brightness. Okay. So 98 is a smaller number, 109 is a bigger number, but 109 has lesser brightness compared to 98, which is having more brightness. So keep that in mind. This will give you somewhat the tight range of the normal brightness of SS Cygni. That is, we can say that it is somewhat, it is brighter than 80, I mean, brighter than something like, how do I choose? Brighter than 128, but less brighter than maybe 109. So you can estimate somewhere around 120-ish. Okay. 120-ish, and you can take that range. Okay, so this is a visual estimation that you're trying to give. And yeah, so you can probably come down to, let's say, uh the exposures are somewhere in between. If we compare 109 and 98, it is not definitely as bright as 109 because it has to fit in this circle, and this circle seems smaller than 109. So it is somewhere more than 109, right? And it is not as small as 128, or it is not as small as 134. The closest is 128. So again, you try to okay, so better than 109, you can take 119. 119 is still kind of a little bit bigger than your variable star, and there is 128. So it is somewhere in between 119 and 128. So according to your visual estimation, you can create somewhere around, okay, it's 120-ish, 120, 121 maybe. So you get a particular range that is fit in your head, right? So that range will tell you, okay, for the safest, we'll take a range of 120 to around maybe 122. So you have a very close range here. Has everyone understood what I meant to say here? Guys, can you let me know if you have understood what was meant here?
Not exactly, madam.
Sorry?
Not properly clear. Intensity, magnitude, lesser brightness means higher magnitude, less magnitude means more brighter, right?
Exactly. So what I'm trying to say here is, uh, you can see the star, the cross hair that is shown here, right? This is the size of our star. Okay. Now, if this is the size of our star, we have to visually estimate what might be the magnitude of the star. To visually estimate it, all you have to do is try to find something closest to this size. Okay. Now I'm saying
Madam,
119.
excuse me, madam.
Yeah, 119.
Madam, magnitude means
Sorry?
we are calculating diameter something or brightness, like
Yeah, based on the brightness.
based on brightness. Okay.
Yeah. So on this chart, whatever these images or these dots are put like a pictorial format of your brightness. Okay.
Okay.
So 119 is somewhat similar to this circle, but 119 looks bigger than that circle, right? So it has to be a star that is lesser, less brighter than this magnitude. So when I mean less brighter than this magnitude, it will be more in number than 119. So it will be
Okay.
more than 119. Only then the size can be smaller than this. Now let's go to 128. Now this is 128. Okay. Now 128 is kind of, what do you say, very small compared to this circle. So since it is smaller and has 128, to make this circle bigger, you need to have some value smaller than 128. Okay. So let's assume our circle size is between the range of 120, that is slightly more than 119, and in between 128 or 125. Okay. Now, if you try to superimpose this circle with 123, maybe it'll be more or less similar with this 123 circle. So you can estimate and you can have a visual estimation in your mind saying my star or my variable star could be somewhere in between 120 to 122. That is just a visual estimation that you can do. All right. So your visual estimations will obviously help you in your future analysis. I mean, I know it doesn't sound very accurate, but that visual estimation will help you eliminate a lot of other, possibilities so that it'll help you bring down your list so that later when you do your trial and error method, you will be able to do it in a faster way. Okay.
Okay,
Yeah.
madam.
Now,
Mobile
what
number.
are the various things that you can learn from this chart? You can, for example, locate the target
90.
star that is in the middle because of the, what do you say, the crosshair thing.
4700.
You can choose some good comparison stars, like, for example, the magnitudes that are already appearing on this chart. You can use comparison stars. For example, I think in this bunch, can someone tell me what could be a good comparison star
एक बार चेक कर लीजिए
for
सभी में स्टैम्प
my
डाला
variable
क्या
star
मैं तो जल्दी
SS69?
में कर दिया
128.
128, huh?
हाँ नीचे में
Don't you think 128 is too small for this? We have already
That's
established that it is bigger than 128 and it is smaller than 119. Now, according to me, see, you can go around and check other stars also. Okay, you have some mentioned here, see all these here. You have a lot of options scattered across the chart, but it's always good to see something that is on the closest vicinity because that will be more visible to you on a telescopic image as well. So wherever you see your target star, you can plot your comparison stars somewhere in the same vicinity. Now, according to me, I would choose something in the range between 112 that sorry 120, that is 120, that is slightly smaller than 119, bigger than 128. Okay. So That will bring me somewhat to 123.
ऑन करेगा
Okay.
वो
Now to
उसको ऑन
confirm
कर
this, I would
सबको दे
इसमें दे
also
दीजिए
try to take a scale of this, superimpose
ये
an
है
image
क्या?
of this onto
मैं
this
इधर
circle
फर्स्ट
and
तू
see if I'm
कलेक्शन दो
able to fit it in that
अभी
circle.
मैं बिजी हूँ, आधा घंटा बात करें.
If it fits
पता
perfectly,
नहीं क्या
then
आपको
my
ये था कि नहीं
next
जब बैठना
comparison star
जैसा
for SS
नेट
Signi
नेट लेना है.
would be number
नेट से ये
123.
इधर लेना है.
वो आज पट्ट ऑन कर को दे
Hope that's clear.
मैं आज पट्ट ऑन करेगा
ओके मैडम.
Hope that's clear for everyone.
वो हमारा मेरा फोन को वो
Yes, ma'am.
All right. Okay. Now, we can also understand the local star field density. Like it is useful when you're hunting for some faint stars or you're trying to avoid
इससे इधर
any
लेना है.
blending of
इससे
stars,
इधर लेना है.
etc. You will be able to identify some
नेट ऑन
local
है.
star
हाँ,
field density as well.
मेरा मेरा
Then it is also important
नंबर
that you check your FOV,
आज पट्ट
whether your FOV matches your telescope or your camera. So if you're observing live, then it is important that you check if your field of view is matching for both. Like here, it is a 1 degree.
फुल नाइट करना है.
The previous chart I took was a 6 degree of the sky. So it's important that whatever you're checking, the chart you download should be of the same FOV as the telescopic view that you're observing as well. So when you observe through a telescope, you will be able to see the settings of the telescope or the camera that you're using. Uh,
हो गया.
you will be able to see it on the settings of what FOV are you looking at. So the same FOV you can put onto this chart generator as well, and you will be able to get the similar FOV. Okay. Now, even if you're looking through a telescope or if you're looking through a binocular, like a powerful binocular, or if you're looking through some sort of, what do you say, some sort of CCD camera or something. Also, you can plan for exposures of your camera based on your magnitudes. Like your brightest comparison stars can give you like 5 to 8 magnitudes, and your faintest one can give you around 14 magnitudes. So you can plan your exposures as well for that matter. And yeah, so the main idea of this is that a visual observer will learn how to estimate magnitude by comparison. And if you're a CCD observer or through a camera, then you will learn how to, which stars to use for reference or various checks and comparisons. Now, now we'll try to go and see what happens with the photometry chart, right? Yeah. Now here, I'm not changing any other data. I'm just keeping photometry instead of chart. Okay. Yeah. So here you get a table like this, and also where's the okay. So in this yeah. So this table will give you a wide what do you say? Idea about what you just watched on your chart, right? Now, AUID is the specific ID assigned to certain stars, and some precise coordinates for each star that you saw on the chart. And even so, along with the ID, it'll give you some right ascension and declination. So those are based on the coordinates where these stars are present in. It's at this much degree right ascended and this much degree declinated. So that is what gives you a sort of idea for where exactly the stars that you observed on the chart are. Now, the label is what the numbers that you had seen on. So for me, number 123 appeared to be the closest, or the kind of more apt for my star. So yeah. So here you can see some comments as well. When you see comments, you can see 123 is what I chose. Now, 123, they have commented that this star is a micro variable and do not use as a CCD comparison star. Now, if I'm just a visual observer and trying to plot based on visual observation, I can use 123 as my comparison star. But if I'm using a CCD comparison, or if I'm observing through a certain camera, then I'm not advised to use this as a comparison star because of certain declination values and how micro variable these stars are. So according to that, you can again go back and check. Like 121 also seems like a plausible option for me. So I can go back and check if 121 looks accurate or kind of close on a visual note, if I can go for that. Right? Yeah. So these are the labels. Now, based on these labels are named in such a way that if you see a label of 92, then your magnitude is 9.2. Then, if it is 108, then your magnitude is 10.8. If your label is 137, then your magnitude is 13.7. So that is how your labeling has been done. Okay. Now, V is basically a catalog of V magnitude with some uncertainty that is given here in brackets. Now, for example, like if you go to 92, right? You have 9.153 and there is an uncertainty of 0.034. This means V filter, that is visual filter, has a magnitude of 9.153 and plus or minus
इसमें एक
0.034.
कॉपी
Now,
आपका
this
एक
is
मेरा
exactly what I told you. Like, for example, if I take 92, right?
तीन तीन कॉपी
92 is the label, but my magnitude is 9.2. Now, 9.2 is a round off number. It is the accurate magnitude here is 9.153 plus or minus 0.034.
रिटर्नेबल आउट
That is how you take
आउट
your error consideration into your
आउट है ये
magnitude. Hope this is clear for everyone. Any value you take, for example, 116,
आउट
if you take the magnitude, we might just consider 11.6, but your magnitude accurately to the point is 11.617 plus or minus 0.056. Hope that's clear.
ओके मैडम
That's okay. All right. Now you have your BV, that is your color index, that is useful for some color terms, transform corrections, etc. Now BV is what gives you the temperature variations. That is your basic filter to your visual filter. Now basic filter and visual filter will have some differences in colors. Like visual filter will give you a bluish tint. So now this filter transformations or the color term transformations will give you an idea when you work on websites like what do you say, Muniven, Hope, etc., that I had discussed in previous sessions. Now those will help you identify what are the temperature variations that take place. So this is again the magnitude that will show you the transformation plus or minus the error. Now, these are the various aspects you need to take into consideration. And also, your goal with this, yeah, okay, again, if I come here, they're also giving you a footnote of what is taken from what source. So you will be able to identify what images on the chart were taken by what source. For example, you might be familiar with Gaia DR2 and Gaia DR3. So number 48 and 49 were taken by these two sources. So what or who has taken or what organization or under what name, like for example, let's say Number 50 could be taken by one of you, and you can name your name here. So that will be your source that is available to everyone. So anyone who is checking for a star number 50 on this platform would be checking and seeing that the source is by so and so person or so and so camera. Whatever name you would like to name, you can name it as well. So that is one really cool thing about it. Now, the goal of this whole chart and the variable star plotter is to identify a comparison stars that are close on the sky to the variable, our target variable at closer to that, and also have similar brightness to the variable of your expected state, and also have a similar color to reduce some color term errors as well. Now that you will be able to see only when you go through the whole image image processing and superimposing, etc. And you will have the smallest catalog uncertainties. Okay, now when you compare your star with some other star, you should have some errors that are really minute, or at least it can come to various decimal points away, so that you can neglect it. Now, from your table, we can identify, like, for example, if we take our primary comparison to 92, for example, if we take 92, we can see that the visual magnitude is around 9.153 plus or minus 0.034, and your basic to visual filter is giving you around 1.046. That is good magnitude, but the uncertainty is very low, and the color is reasonably red. And SS Cygni in our case is more redder, that is close on chart. Now let's say, okay, you have ignored your 92. Okay, you've given for a secondary comparison of 98. Okay, 98 again. You're coming down to 98, and you're looking at the V, that is 9.794, and you have an error of 0.071,
Mobile
and you
number.
have a basic to visual filter of 0.368.
One second.
Now the color mismatch is happening here,
974241.
because here in 0.368 you're seeing it is more tending towards a blue color. Okay, so towards your visual filter you have a more bluer color because it's coming to this range. And it
इसका
so
print
so
दीजिए ना.
your SS Cygni is more of a red color, so this is not a good
Thank you.
comparison to look into. Now we're way coming down. Let's consider 103, or some sort of 103. Let's consider 103. So again, it is having a 10.279, and it is having a sort of a good error, and your B2V is coming around 0.433. It is sort of good as an independent check, but again, it is making your SS Cygni more fainter or brighter, so it is not falling in the right category. Then you even come further, you can check 121 or 123. It might seem more appropriate for your comparison. Now, this is where your initial visual observation comes into picture. If you have not checked on your chart and tried to analyze visually based on what star could be a good choice of your comparison star, then you will have to go through a trial and error method that goes down to all these values. Right now, like, we checked in individually each star. So since that can be avoided, you can come down to a position where we understood that our star could be somewhere in between 119 and 128. So you will have to check only the stars, only these three values, and you will be able to identify one apt out of these three options. Hope you have understood the importance of visual estimation from the chart. It might sound a little stupid when you check it from the from the chart, because comparing with the crosshairs, circle, trying to place one there and trying to see what could be fitting inside that circle. That might sound a little stupid at that point, but when you come here and when you try to confirm your comparison stars based on various other filters and various the error capabilities, etc., it would give you an easier choice when you come down and from the chart you try to understand that it could be between 119 and 128. So whatever comes in between 119 and 128, only these three values you will have to analyze.
Madam,
Hope that's
no, madam.
yeah, please
Madam,
do.
comparison star, how you selecting? Little explain again.
Sorry, can you come again?
Comparison star, how you selecting? Will you say again? Little. What
Yeah.
factor you
So
are selecting?
comparison star, if you go, yeah, no problem. Comparison star, if you go to your chart, right?
Yes.
If you, okay, I will go back to the chart. I think star chart. Yeah. So if you go to your chart and you observe what is here, right?
Yes, madam.
Your star, your target star SS Cygni should fit in O. Okay.
Nearby star we have to
Should fit.
select, but in the
Sorry?
in the here nearby star we are selecting, but in value list how you selecting the comparison star with respect to data
Oh, okay, like that. All
numerical
right,
value.
all right. I'll go back to that. Yes.
From here,
Yeah. Okay. So from here, what happens is, first off, you should understand that the error has to be somewhat negligible, right?
okay,
So
ma'am.
error should have somewhat a negligible rate. Okay. And so let's say from your chart, you understood it's between 119 and 128. So you have these three options to choose from. Okay. Now here, um, you have a B2V. Okay. This is your B2V. Now B2V is nothing but your basic filter to visual filter. So as I mentioned in the slides, the PPT that I showed at the beginning of this session, your basic filter to your visual filter should give you a comparison of how much it'll go from red to blue, right?
Mm,
So red to blue, that transition is what is shown here. Okay. So in these three, for example, this 121 is a bigger number. So it means that when it is going from a red to blue, it is having a better, a heavier weightage on the red side. Okay. So one is a bigger, like this is a trick I'm telling you to understand.
okay, ma'am.
So if you have a lower number, for example, 0.529 compared to 1.046, 0.529 is a smaller number. Now, smaller number means it is coming lesser towards the visual filter. Okay. So this transition from, let's imagine this as B is the red and V is the blue, right? So when it is coming from red to blue, smaller numbers
Sorry, madam.
will indicate that blue is more and bigger numbers will indicate that red is more.
Madam,
Okay. So when you come to,
madam, sorry, madam.
sorry, yeah.
B for red and V for blue.
Uh, no, it's the other way around. V
Uh,
is the visual filter, which will give you the blue.
V for
Yeah.
visual filter.
B is the basic filter that will give you more red tint.
B is basic filter or V is visual filter.
Visual filter.
Okay.
Yes. Yes. So if you take this, for example, 1.035 will give you somewhat a heavier side on the red. That is your basic filter.
Basic
Okay.
filter.
Now you know your SS Cygni is a redder star. Okay. Now you have a choice that where you have to make saying, okay, my star is more redder, so I need to choose an option that is giving me more red.
Okay.
Hope you have understood.
Okay, madam. We have to choose
Now,
basic uh,
more of
value.
a basic filter outlet.
Basic.
Yes, yes.
Okay, which parameter have more basic filter value? That star we have to select.
Yes. Now, I've chosen basic filter here specifically because we know the history of SS Cygni, right? We know that SS Cygni is more of a red star. That is a red supergiant or a red giant. Okay.
Okay.
So now, based on for SS Cygni specifically, since I'm looking for SS Cygni, I need to have a comparison star that is having more red on it.
Okay. Similar to SS
More
Cygni.
redder, which means when I say a star is more redder, what I also mean is that star is not very hot.
Yes, yes.
It is cold,
Cool.
right? Now, if I take any other values, it is more estimating towards the blue filter or the
Blue
visual
filter.
filter, which means it is more hot.
More hot. We have to select a similar type of SS Cygni star, which
Exactly.
what color SS Cygni presenting. Suppose SS Cygni is red, then red value is 1. Suppose then similar type of star, if there is 1 value, then we like this we have to identify that comparison star. I am clear?
Exactly. Yes.
Okay, madam.
Now, the main reason we are trying to find a comparison star from this database is that let's say, we don't know much about SS Cygni. We don't have a lot of values about SS Cygni. We don't know how to analyze SS Cygni. Now, we are trying to find a similar magnitude star, which is having a similar magnitude to SS Cygni, so that we already have the available data based on this similar star. Now we try to compare it and we try to understand SS Cygni.
Yes, madam. Yes. Okay, madam.
Understood?
Understood, madam.
Like, for example, if you let's say you want to take a certain color cloth from a shop. If you want to buy a certain color cloth or certain material from a shop, okay,
Compare should be with the
rather than
same type of cloth.
exactly. So you take a sample of the same type of cloth and you go to the shop and you show it and say, okay, I
This
already know about this cloth. So can you give me the same kind of cloth? So this is like a reference so that you already know the data about this star. So you will be able to analyze and see if you know how much of this star can help you to understand your SS Cygni.
okay, madam.
Understood? Okay.
Okay.
So this is how you finally come to one of your best options. Now we come to a conclusion wherein 121 can be our reference star.
Yes, ma'am.
Okay, our
Yes.
comparison star. Now that is the assumption we are trying to move forward with.
How
Okay,
many one we have to find out comparison star?
you
Two
just need one comparison star.
one's comparison star.
One is enough.
Okay.
Okay, yeah. Now, there are some practical aperture photometry settings, etc., that you can, take into consideration as well. Also, some color term filter guidance, etc. Now, this is what I primarily wanted to introduce you into. You have a small activity which you will have 3 days time for. Within the 3 days, I would like you all to. Okay, I'll show you.
Another comparison. Madam, what is the use of CCD camera, madam?
CCD camera will give you a lot more clarity because CCD camera primarily uses charges in that. It is more calibrated using charges, and plus it is maintained at a very low temperature. That will help low temperature because the camera is very sensitive. Now, due to the sensitivity, it will give you a more refined image.
Okay, with the help of this camera, we what things we can observe, image or any temperature value or any frequency type of things like this.
You mean like what all can be observed
With this,
using a CCD camera?
yes, madam. What we
Yeah,
can
CCD
get
camera
data.
can, yeah, so CCD camera can observe anything that you're observing through a telescope. It will just be captured at the right clarity that you're looking for through the telescope. Right. So
Okay.
since it is based on charges and it is based on charge coupling, so these work on specifically on some certain charges that is being excelled. Now these charges will give you due to the sensitivity and all that, it'll be able to plot the exact spacing of the images that you're observing for, and the clarity will also be much more enhanced than any other cameras that you use, like for example DSLR. All these will have great limitations on the charges.
It means we can extract any type of data in very details manner.
Yes, yes. So anything, see, uh, you observe something through your telescope and you connect it to a CCD camera, and the CCD camera is just recording what you're seeing. Now, this recording happens more, more
Details in
in a more clarified way
clarify.
through
Okay.
your CCD camera. And all the noise that comes with your image capturing, all those extra noise, all the grainy textures, all these could be reduced to a great extent using a CCD camera.
Okay. It is costly, madam. With
Sorry,
this camera is heavy costly.
I didn't get you. Are you asking me if CCD cameras are more costly?
Yes, yes. Is this camera is heavy costly?
Yes, CCD cameras are comparatively more costly, but most of the observatories these days are trying to install a CCD camera because that gives them the most refined images. And also, since the noise is less when CCD cameras are used, it'll cut down a lot of steps that they have to go through, and a lot of rendering can be reduced. It is more time efficient if you use a CCD camera because a lot of the noises will be cancelled out right when you capture the image.
Mm.
So for
Okay.
that reason, the observatories, at least to a limit, are trying to install CCD cameras, although it is more expensive, but the setup is worth it. And plus, maintenance is also a little too difficult for CCD cameras. Like you can't keep it in normal lighting. You can't adjust the temperature. You'll always have to keep it in a very low
Separate setup.
low temperature. Sorry.
We need separate setup and environment to
Yes,
maintain
yes,
this.
exactly, exactly. Yes.
Okay.
Yeah. So, anyway, the activity that I want for you all to do is one, you will have to complete any one video out of this, out of these tables that you see. It has videos, sources, PPTs, etc. So you can go through and watch any one of these, or you can go through any one of these documents and write uh, a, 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 a culmination of what you understand from these, any one. And plus, I want you to go collect a variable star plotter chart as well as a photometry chart. Okay. Variable star plotter. Here you can change chart and photometry. So I want you to choose any star of your own interest. Choose, create a chart and create a photometry chart. And based on all the points that I've discussed today, try to make a write up of what all you have understood and what comparison star have you chosen. Hope that's clear.
Okay, madam. Okay,
Okay.
okay, okay. Sir,
All right.
madam,
So you have two small tasks.
one second. Only we have to provide here. Give a input of name of the star and choose a
Uh,
prefined chart
chart
scale.
scale.
What value we generally
Yes.
60 fixed, madam?
60
60.
is what I choose. You can, explore it by trying to give the same chart, see 120 arc minute, and see how your scale changes. If that is more convenient for you, you can choose that. See, this is basically how much you want to zoom in and zoom out. Okay,
Okay.
so G would be zooming out the most, and A would be zooming in the most. So it's always safe to stay somewhere in the middle, that is C or D. So you can choose C once and check how your chart is coming out. If you feel like you are able to, plot everything from that, you can go for that, or you can choose D and see how you want your chart. All right.
Okay. Generally, we will use D, right, madam?
Yeah, sure, sure. That's up to
Okay.
you. You can choose C or D
Okay.
and see how your results are coming out.
Okay.
If you're able to, if it is whichever is comfortable for you to identify the neighboring stars, that you can do.
Because we
All
don't
right.
know
And
details so much, so that's why I
sorry,
asking. Because I don't know so much of C, D, G, so that's why I
no
asking.
problem. So that's why I'm telling you, you can, okay, let's say you go to C. Okay, plot chart. Oh, sorry, chart, plot chart. Okay, now you will have a chart plotted in C. Yeah, so now you see the stars are much more smaller.
Okay.
Yeah, so this is slightly difficult for you to understand what could be bigger, what could be smaller. You remember how big 86 was in the other one? It was a big round circle. Now it is much smaller. So this is slightly difficult to understand. Okay, so you go to D. That is slightly more better. Now this is a better graph. Now, again, that will depend on the kind of star that you're choosing, what you're trying to observe, what kind of sky the observations are put in. So it is better you see two, three options and see which is more easy for you to understand.
Okay,
Okay.
madam.
So in your case, since you're not using any CCD camera or any setup telescope, you can use visual, and you can go for chart as well as photometry. If you want any advanced options like field of view changing, magnitude limit changing, you can always play up and down with it, and you can see what kind of photometry you want to go for. Now, all these based on, you can change, and you can, come up with different options and write up what options you have come up with on your little synopsis or the inference that you're writing on this. Also include a screenshot of your variable star plotter, the chart, as well as photometry table. Also make sure before that you go through some, if you go to the main screen and see this new observer start here, you'll be able to find a lot of videos, lot of materials. So go through any one of these and you write what you understand. Hope you're clear.
Mm, Madam, photometric chart and another chart you shown. What what basic
Yeah.
things we have to
So
write in? We have to mention
yeah, photometric chart as well as the VSP chart,
chart
variable star plotter chart.
within these
So
two
you can
chart.
show,
Within these two
yeah,
chart,
when,
what we have to mention means what I have understand or any other specific things.
yes, from what all we have discussed today, you will be mentioning about how the magnitude is changing and what do you think is the most
Uh,
adequate comparison star for
Comparison
yours.
star. these two things
Okay.
or
Yeah.
nearby. Okay,
All
madam.
right. Okay. And yeah, that is the major task. Also, you should complete any one module or any one material from this table. Hope that's clear.
Okay, madam.
Okay, so that's about it, people. I'm stopping the uh yeah, stopping the screen share. If you have any doubts, please feel free to ask, or if we don't have any more, we can call it a day.
Okay, madam. Thank you, madam.
Thank you.
Good night, madam.
Good night.